Assalamu alaikum students, welcome back to my channel. My name is Samar Noreen and as we are going through the series of name reactions, today our concern is with Michael addition, which is also very important name reaction due to its wide applications in chemistry. Michael addition is a bit related or similar with Aldol reaction, but here according to its chemistry as enolate formation, which would act as nucleophile, same in aldol condensation. We'll notify the differences between aldol and Michael addition also. So before starting the video, don't forget to subscribe my channel so you'll be notified for more. So let's have a Michael addition reaction. In this reaction, this is uh, nucleophile in which this methylene would be surrounded by two groups R and R dash. These groups are electron withdrawing groups, may be acyl or cyano groups. Due to the presence of electron withdrawing group, the methylene group here becomes more acidic, and therefore the base would attack on this carbon and abstract proton from here and convert it into the enolate, which would act as nucleophile. Another reactant is alpha beta unsaturated carbonyl compound. This R dash dash is simply a carbonyl compound, and these are ketones having alpha beta unsaturation, and as a whole, it is called enone. And this is also called activated alkene. How is it activated alkene? Due to the presence of carbonyl group, which makes it activated, and this site of this compound becomes electrophilic. So the enolate or the nucleophile would act as Michael donor, or one species which would attack on the alpha beta unsaturated carbonyl compound would act as Michael donor, and this is the Michael acceptor. And the resultant would be 1,4 addition. This would, if we consider the position 1, then 2, 3, and 4 as compared with respect to the carbonyl group present here. So this is the 1,4 addition, while aldol is basically 1,2 addition. So let's have one example here. Here we have 1,3-diketone. From 1,3-diketone, due to the presence of two carbonyl groups, this methylene group having hydrogen, these hydrogens become more acidic. So the base would abstract proton from here and convert it into enolate. Like this. This enolate is resonance stabilized. Here we have a resonance stabilized enolate. Resonance stabilized enolate are weak bases. Therefore, we use specifically these enolates, or these compounds 1, 3, or surrounded by two electron withdrawing groups. And you'll know the reason why we choose these when we have a comparison of two enolates. So this enolate would attack. Now this compound, which is Michael acceptor, have two electrophilic center. This carbonyl carbon here and this beta carbon. So if we use the weak base or nucleophile, this weak base would tend to attack on beta position. However, if we use a strong base or a strong nucleophile, then the carbonyl carbon would be attacked by the nucleophile. And this is the difference basically in the aldol and Michael addition. In the aldol addition, directly 1,2 addition takes place between the enolate and the carbonyl compound, because enolate would attack directly on the carbonyl carbon. However, here the alpha beta unsaturation makes another electrophilic center, and enolate, which is basically a weak base, would tend to attack at this position, beta position or beta carbon. Now this would attack here and bond shifting occur like this, and we have this compound. If we consider it position 1, this is 2, 3, and 4. That's why this is 1,4 addition. And after having this compound, after protonation, would convert into an enol. This moiety is called enol. This is an enol, which on tautomerization, how like bond shifting occur like this, and after tautomerization will get 1,5 dicarbonyl compound, or 1,5 dioxygenated pattern will get in the final product of Michael addition. 1, 2, 3, 4, 5. This is the final product we have for Michael addition. Let's have another example in which we have more electron withdrawing group. Like here we have an ester group on both sides of methylene. So this react with this cyclic structure or cyclic alpha beta unsaturated compound, alpha beta unsaturated carbonyl compound, and resultant product would be this. And by following this mechanism, like enolate formation first occur, like base would attack here and convert it into the enolate, and after enolate formation, enolate would attack on the again beta position to the carbonyl carbon or carbonyl group. This is the beta carbon, and after shifting of bonds, we'll get the compound this. This compound on having proton from protonated base would convert into this compound in which we have enol moiety here. This enol moiety again on tautomerization gives the final product. It's a very simple way followed by the Michael addition reaction, and it's very interesting to have this mechanism, very simple and easy to go mechanism of the Michael addition. And this is our final product of this reaction. Now let's have a comparison of two nucleophiles for Michael addition. Here we have this nucleophile which we use in the Michael addition reaction, as both of these are electron withdrawing groups, R or R dash. Both of these are electron withdrawing groups. This compound or 1,3 dicarbonyl compounds have pK values about 9, around about 9. And this compound, which have only one carbonyl or electron withdrawing group, this compound has pKa 20. So the strong the acid, weak its conjugate base would be. That's why if we convert this compound into enolate like this would be a strong base, and this would tend to attack on or this would tend to attack on carbonyl carbon, and these two attacks at at beta position and at carbonyl center would be competing for this compound. That's why we don't use so this would give a competing uh, electrophilic center like beta position and carbonyl carbon, and the mixture of products may be formed and not good for the Michael addition. So that's why we use the nucleophile which have electron with drying groups on both sides. So that would give weak bases, and weak bases would tend to attack on the beta carbon here and result the Michael product or Michael addition product. Thank you so much for watching. I hope this video will be helpful for you to understand Michael addition, and don't forget to subscribe my channel for more videos.